You know, fishing has been around forever, right? It's one of humanity's oldest industries. But what happens when you smash that ancient tradition together with some seriously cutting-edge physics and data science? Well, you get a revolution. So let's dive in and see how technology is completely transforming the high seas.
So here's the big question, isn't it? It's really the core problem for the entire global fishing industry. How do you get better at catching the fish we need to feed everyone while also protecting our oceans for the future? I mean, it sounds like you can't have both, but as we're about to see, the answer lies in some pretty brilliant science.
Okay, so before we get to the really cool solutions, we've got to understand the problem. And for decades, the industry's answer has basically been the same thing over and over. More power. Just sheer brute force.
Just look at this trend. It's wild. Over the last 50 years, the engine power on a typical fishing boat has absolutely skyrocketed. We're talking a 7-fold increase, from around 700 horsepower to nearly 5,000. And all that extra power? It just means you're burning a massive, massive amount of fuel. It's basically an energy arms race out on the water, and it's just not sustainable.
But what if you could swap out all that brute force for brains, for pure intelligence? That was the whole idea behind a company called AcruxSoft, which got started back in 2008. They brought together these sharp minds from universities and seasoned experts from the fishing industry to tackle this exact problem. And their plan wasn't bigger engines, it was smarter tools.
So if you're gonna build smarter tools, you first have to understand the invisible battlefield, where all this fishing gear actually works, and that is the world of underwater hydrodynamics. It's all about mastering the forces that are constantly at play just beneath the waves.
All right, first up, the main villain of our story, drag. Just think of it as water's version of friction. It's the force that's always pushing back against the net, against the boat. It's the thing you're burning all that fuel to overcome. The math is simple. More drag equals more fuel burned, period.
Now, the hero force here is lift. And yeah, we usually think of lift when we talk about airplane wings, right? But it works the exact same way underwater. For fishing, you're using lift to spread the mouth of that giant trawl net wide open. So the name of the game is to get as much of this lift as possible while creating the least amount of drag.
Here's a really simple way to see how this all works. See this buoy? When it's just sitting still, at 0 speed, nothing's happening. But the moment you start pulling it through the water, 2 knots, 4, then 6, you see those forces, lift and drag, just kick in and they grow like crazy. It's exponential. Understanding this relationship is the key to everything that comes next.
Okay, so once you've got a handle on the physics, that's when you can start redesigning the gear. And this understanding, well, it leads to some truly incredible engineering and equipment that is just radically more efficient.
All right, let's start with the trawl doors. You can basically think of these as the underwater wings for the whole system. Their one and only job is to generate that hydrodynamic lift to pull the net open. And the difference between the old way and the new way is, honestly, it's staggering. To get the same amount of spreading force, an old-school, clunky door needed over 11 square meters of surface area. A modern, hydrodynamically designed door does the exact same job with just 4 square meters. That's 175% less area creating drag in the water. Less drag, less fuel. It's a huge deal.
And here's the hard data to back it up. This table compares 4 generations of these door designs. You can see it right there. The lift coefficient, that's the good stuff, is going up. And the drag coefficient, the bad stuff, is going down. But the number you really want to look at is in that last column, overall efficiency. The latest design is over 3 times more efficient than the original. That is just a massive leap forward.
Okay, so the doors are a huge improvement, but they're only one piece of the puzzle. Now let's talk about the biggest, most complicated part of the whole system, the trawl net itself.
Now this is maybe the most important point of all. The net itself, just the netting, is responsible for a whopping 55% of the total drag on the entire fishing system. Think about that. That's more than the doors, the ropes, and the weights all combined. So if you really want to save fuel, you have to design a better net.
And believe me, a modern net is an absolute masterpiece of precision engineering. We're not just talking about a big bag. We're talking about optimizing every single detail. The exact thickness of the twine, the size and shape of the mesh, the materials you use, even the precise angle that every single panel is cut and sewn together. It all adds up.
And this isn't just about burning less fuel. All this engineering has a huge sustainability benefit too. See, by carefully designing the mesh size and shape, you can actually design it to be selective. It can catch the fish you're targeting while letting the smaller, non-target fish swim right through and escape unharmed. That means way less bycatch, which is fantastic for the whole ecosystem.
All right, so we've got the gear totally optimized, but the next level of smart fishing is about optimizing the entire operation. It's not just about how you fish, it's about being in the right place at the right time.
And what this really means is using massive amounts of data. We're talking ocean currents, water temperature, the topography of the seafloor, historical catch data, and you feed all of it into models that can actually predict where the fish are going to be. It's about shifting from fishing with luck to fishing with data.
And this isn't just some theory, you know? This data-driven approach is already being used for some of the world's most important commercial fisheries. It's helping make the hunt for things like hake, squid, red shrimp, and anchovies way more efficient and targeted.
Take the Argentine hake, for example. By modeling its seasonal migration patterns, fleets can predict where these massive schools will be concentrated month by month. What does that mean? It means way less time just steaming around, searching and burning fuel, and a lot more time actually fishing productively. Plus, you get a much better understanding of the species' whole life cycle.
So when you put all these pieces together, you've got the physics, you've got the high-tech engineering, and you've got the data science, you start to get a really clear picture of what the future of fishing actually looks like. It's a completely fundamental shift in thinking. The old way was just more horsepower. The new way is all about applying smarter hydrodynamics. It's a move away from brute force and towards, well, scientific elegance.
You know, this quote here really just nails it. True productivity isn't just about how big your engine is. It's about mastering the entire system, the vessel's movements, the underwater physics, and the complex hydrodynamics of all your gear.
And that leaves us with one last big thought. Fishing is just one example. So it makes you wonder, how many other old-school industries, from farming to shipping, are still just running on brute force, waiting to be revolutionized by a deeper understanding of their own hidden physics? It's a powerful idea to think about.